toxins which have been used in the studies of this receptor. But first I would like to give some short introduction to snake venens. There are about more than 3,000 snake species at the present known, and among these I will try to speak louder. And among these 3,000 species, about 400 are dangerous for human beings. This 400 belongs to the two main families. This is Elapidae, which include cobras, crabs, and sea snakes, and Viperidae, which includes common vipers, pit vipers of New World and of Old World. These snakes differ not only in the appearance and behavior, but also in the venom composition. And they can be roughly divided in two groups from Elapidae family, which contains mainly neurotoxin and cytotoxin. This is non-enzymatic proteins, as well as some phospholipase A2, other enzyme, and some other components. While the Viperidae family contains mostly enzymes, among them metalloproteinases account for about 50%, then serine proteinases, and again phospholipases. Today, there are more than 3,000 entries of snake toxin in UniProt database bank. Among these, more than 800 represented by three-finger toxins and more than 600 represented by phospholipases A2. And these two families of toxins might be regarded as a classical toxin. And I will speak in details about three-finger toxins first. These toxins include many types, and those which have been used for the receptor studies are represented by three-finger neurotoxins. There are several types of three-finger neurotoxins, and they differ by amino acid sequence and number and position of disulfide bridges. Long toxins contains 5 disulfide bridges, and the 5th disulfide is in the second loop. Short neurotoxins contains only 4 disulfide bridges and no additional 5th disulfide, and so-called weak or non-conventional toxins again contain 5 disulfide, and 5th disulfide is located in loop 1. This three-finger neurotoxin differs not only by the structure but also their affinity to nicotinic acetylcholine receptor, and this is summarized briefly on this table. Short neurotoxins target torpedo and muscle type nicotinic acetylcholine receptor. Long neurotoxin, in addition to muscle type, also target pentameric neuronal acetylcholine receptor. So-called kappa neurotoxin, they interacts with neuronal heteromeric receptor, and weak toxin binds to muscle type neuronal, and in addition to nicotinic acetylcholine receptor, they also interact with muscarinic acetylcholine receptor. Just briefly summarize the data about receptor of cis-loop family. Nicotinic acetylcholine receptor has been described in detail in the morning session, as well as inotropic GABA-A receptor. They have quite similar spatial structure, but differ in their conductivity. Acetylcholine receptor possesses cationic conductivity, and inotropic GABA receptor conduct selectively chloride ion. Nevertheless, they have very similar structure, and this led us to the idea to check neurotoxins which bind to acetylcholine receptor on this GABA-A receptor. and this has been done, and Victor has shown this slide already, but I would like to say that this is electrophysiology traces of the current induced by GABA-A in the oocyte is expressing this particular subtype of GABA-A receptor, and the current induced by GABA are blocked by different neurotoxins, and it can be seen that most active is α-bungarotoksin, while on nicotinic acetyl-choline receptor most potent is α-bungarotoksin. Then, taking these toxins as an we have checked the affinity of this toxin on different subtypes of GABA-A receptor, and has found that the affinity of receptor composed of different subunits also differ in the affinity to α-bungarotoksin. And the most active is alpha-1 beta-3 gamma-2 receptor, and less active this subtype. Then we try to understand what kind of interaction is in this binding. And GABA dose response curve was done in the presence of small concentration of α-bungarotoksin, and we have observed that the EC, the inhibition curve, activation curve is shifted to the right side, and the hill slope is reduced. And this suggests probably non-competitive or some mixed competitive, non-competitive action. Thus, three-finger toxin dose-dependently block ionotropic GABA-A receptor, and the efficiency of interaction depends both on nature toxin and toxin and subunit composition. Next comes phospholipase A2, and this slide briefly summarizes snake venom phospholipase A2 properties. They possess quite different biological activities. Probably it's not possible to find some toxic effect which is not represented by this toxin, and also among others they possess neurotoxicity, and this is still not clear what is the mechanism of this neurotoxicity. We have tried to understand this and have found that phospholipase A2 from different venom, including vipers and cobras and crabs, all of them inhibited nicotinic acetyl-choline receptor. Here is represented the electrophysiology curves indicating that in the presence of phospholipase A2 from one kind of viper, which is functionally inactive, it does not possess phospholipolytic activity. Nevertheless, it suppresses the current induced by agonist in Lemnia stagnalis neuron expressing some kind of nicotinic acetylcholine receptor. When compared to the classical so-called classical three-finger toxin, activity of phospholipases is a little bit lower, but nevertheless it's quite comparable to the activities of lead toxins. For example, phospholipase found in the Vipera rossini venom possess the activity on torpedo receptor, which is higher than the activity of non-conventional toxins. We have observed that again this toxin interact with nicotinic acetylcholine receptor by some non-competitive manner. And we have tried, at the same time it's competed with α-bунgarotoksin for the binding. Trying to understand how it can be explained, we make a dotting experiment, have found that in some experiment this toxin bind at the interface and the membrane interface close to the classical ligand binding site. And this might means that it does not enter the binding site but prevent the α-bungarotoksin by some steric hindrance. And just a very short conclusion that the well-known snake toxin may manifest new biological activities like three-finger neurotoxin on GABA-A receptor or phospholipase A2 on nicotinic acetylcholine receptor. And these properties may add new dimension to the deleterious effects of known toxins. And finally, I would like to thank my colleagues who take part in this work. This is colleagues from Shemyakin-Ovchinnikov Institute, Dr. Wolfius from Institute of Biophysics from Pushkin, Dr. Zickert from Medical University and Dr. Van from Vietnam. Thank you very much for your attention.
Thank you. Well, Yuri was fantastically punctuality. And also I learned that one of the talks will be missing, so we can, each of you can have 2 minutes or 1 minute or more. And that's why we have good time for questions to Yuri, please.
Besides dotting experiments, do you have any experimental data to prove the model that the toxin binds to specific sites and prevent access of the hidden there?
The only experiment data is that the phospholipase A2 compete with α-bungarotoksin which bind to the orthosteric receptor site. We have no other experimental process.
Probably you expected that some mutations are already done, but they are definitely planned, but he keeps the mouth closed. Any other questions, please? Yes.
My question is about the concentration dependence of GABA in the presence of toxin. Can you show me the slide again? It seems that the curve is not saturated actually and in the presence of the toxin.
If you will not find the slide, you will repeat his question afterwards, okay? Because it might take a lot of time.
Somewhere here.
Yes, this one. Yeah, you see the concentration dependence in the presence of the toxin. I do not see the saturation, so it seems impossible to answer if it is.
Yeah, but if you look here, quite high concentration.
So it's impossible to.
Well, okay, I apologize.
Maybe it's possible to use smaller concentration of the toxin to induce smaller shift and finally to check if it is possible to reach the same level of response.
I am afraid that lower concentration of GABA, the current will be too low to...
No, the smaller
Both
concentration
chairmen
of
ask you to continue your discussion
Okay.
after. Sorry, we are really pressed for time here.
We apologize.
Yeah, we are.